All right, so we're going to continue on here with 1.4, um, last part of it. So watch this video, take the notes. Um, if you have any questions, then I'll get back to you Thursday. But I think this should be pretty straightforward stuff, and then you'll have an assignment in my math lab to do. So the last thing we had talked about, if you looked at this last example, again, these are examples from the test, was just plugging these values in. You're going to be given an f of x, a g of x, and h of x. And again, on the test, I might add like 6 more functions. Then I'm just going to simply ask you to add them, to compose them, to multiply them. And then don't forget how to find the domain. If we look at a graphical example here, um, if I have f of x and g of x and ask you to graph f plus g of x, you simply just add the y values, and then that's what you plot. So again, if you're going to plot 0, I would add -1 and 2, and that's where I got 0, or this 0, 1 from. If I'm going to plot the point at 1, I would add 1 plus, or 0 plus 3, and I get 3. So that's where the ordered pair 1, 3 came from. To plot 2, you would add, it looks like here, 1 and 0.5, so I get 1.5. Okay, and so on and so forth. So you just add them, graphing should be pretty simple. So I want to look at piecewise functions and understand what a piecewise function is. We talked about this a little bit, but I want to get into a little bit more of piecewise function and have you be able to actually solve these and graph these. So um, make sure that you understand what this is. It's simply a piece of a function being defined by this domain. I am saying you're only allowed to plug x values in that are greater than 0 for x plus 3. And 2x minus 4, I'm only allowed to plug in x values that are less than or equal to 0. So if I'm asking you to plug in 3, I know that you are capable of plugging in 3 to the top equation and 3 to the bottom equation, but you have to make sure that it is in the domain. So I've got to ask myself, is 3 greater than 0? The answer to that is yes. So I'm going to use this function. So I'm going to plug in 3 for x. Why am I plugging in 3? Because that's what it tells me to do. And 3 plus 3 is 6. So the only answer for f of 3 is 6. If I ask you to find f of -10, okay, same thing. Looking at this piecewise function, I am looking at the domain. What domain is -10 in? -10 is less than or equal to 0. So I would plug it into 2 times -10 minus 4, which is -20 minus 4, which is -24. So I would get f of -10 equals -24. What if I asked you to plug in f of 0? Okay, is 0 greater than 0? No. I would plug it into the bottom equation. So this is kind of I call this the key to a map. Okay, this tells me where I'm allowed to plug it in. So if I plugged in 0, it'd be 2 times 0 minus 4, which is 0 minus 4, which is -4. The math, I feel, is pretty simple. I could be wrong, but I think it's pretty easy. So um, let's take a look at the next slide, which was right here. Okay, so taking a look at this piecewise function, I want you to plug in 3. Is 3 less than -1? No, then I completely ignore the top equation. Is 3 between -1 and 1? No. Is 3 greater than 1? Yes. So I'm looking at this function right here. I'm going to plug in 3 squared and I get 9. So f of 3 is equal to 9. I'm going to plug in -2. Is -2 less than -1? Yes. So I'm going to choose 3x minus 1. 3 times -2 minus 1 is -6 minus 1, which is -7. So f of -2 is -7. I'm going to plug in 0. 0 is between, look, there's nothing to plug in here. I'm literally telling you the answer is 4 when anything is between -1 and 1. Okay. Let's take a look at the last piecewise function here. So find f of 3. So when we look at f of 3, okay, is 3 less than or equal to -2? No. Is 3 between -2 and 2? No. Is 3 greater than or equal to 2? Yes. So I would plug it into x squared plus 1, which is 3 squared plus 1, which is 9 plus 1, which is 10. So plug in f of 1. Okay, is 1 less than -2? No, it's between here, so I get 0, right? -1 or +1 is between -2 and 2. And then plug in -6. -6 is less than -2, so I would choose 4 minus 5x. So I get 4 minus 5 times negative 6. 4 plus 30, I get 34. Okay, so hopefully piecewise functions and solving them aren't too difficult. I want to go ahead and take a look at the graph and graphing these. So first of all, this is going to come secondly. I'm going to show you how to do this in Desmos in a second, but I want to actually graph this. Okay, to graph these are what I call my boundary points. Okay, this right here is called what I call my boundary point. Okay, why is it a boundary? Because it's at -2, and any number less than -2 is to the left. So I'm going to graph these points, okay, based on my boundary points. And I'm going to show you how to do it in the Desmos and the graphing calculator as well. So I'm telling you, I want you to plug -2 in here. Okay, so I'm going to go 4 minus 5 times -2, and I'm going to get 4 minus or plus 10. I'm going to get 14. So the first point I'm going to plot here is -2, 14. I'm going to go left 2, up 14. Okay, so my graph's going to be kind of rough here. 6, 7, 8, 9, 10, 11, 12, 13, 14. -2, 14. So there is that first point. Notice it's a closed dot because it is included because it's less than or equal to. Well, now, where is the next x value that's less than -2? Okay, the next x value that's less than -2 would be -3. I could choose any point here, and I know that this is linear, so I'm going to just form a line going to the left. Okay, so if I plug in -3, again, I would have 4 minus 5 times -3, which is 4 plus 15, which is 19. So I would go over to -3, and I would go up to 19, and that graph is going to look something like this. It's piece of a line. It starts at this value, and it goes forever and ever and ever to all the values that are less than -5. So again, how did I know how to get this point? I had to do some math. I had to plug it in. Okay. Then I know that the graph is at 0, so I'm going to use a different color here to show you where 0 is. Okay, again, f of x equals 0 is just a horizontal line at y equals 0, which would be right here. But notice at -2, I'm going to put an open dot. At 2, I'm going to put an open dot, and it's everything between these two. So it would be this constant horizontal line between -2 and 2. And then where's the graph start back up? The graph starts back up at 2, and it's for this function. So I would plug 2 into this function, and I would get 5, right? So I'm going to plot the point 2, 5. So 2 up 5. Now this isn't linear. So I might have to plot a couple of points. I might need to plug in 3. Where am I getting 3 from? It's the next value that's greater than 2. That's what this is telling me, right? So the next value that's greater than 2. So if I plug in 3, I square it, add 1, that gives me 10. So I plug in 3, 10. Again, this is a parabola, right? We know x squared is a parabola, so it's going to look something like this. So again, a rough sketch. I missed there. Let's go ahead and fill that in. Okay, so a rough sketch of what this graph will look like. Now, again, I can fill these in right here, okay, in Desmos. So if I go to Desmos and open up this graphing calculator, I'm going to kind of see if I can get both of these on the screen at the same time. And I can graph this. Okay, I already put the first one in, but make sure it's a -2. So you see, Desmos does it for me, and it shows, hey, that point right there is included, right? -2, 14. That's how I'm showing with a dot there. Okay, and then the next one I would put 0, and that's in between um, from x is greater than -2. I'm going to close that off and then create a new one, and x is less than 2. Oh, it makes my graph right here. Now look what happens if I go right here. Okay, shows me that those points are on there. It doesn't show that they're not included there though. Okay, this one again shows that. So you got to know that it's not included there. Okay, and then the last graph, if I put it in there, I put x squared plus 1. If I just leave that, it shows the whole graph. Now I'm going to define the domain of x being greater than or equal to, so greater than or equal to, I got to use this, greater than or equal to 2. And then you close that off, the bracket, and it shows the graph right here. Okay. And again, that's where I got my boundary point of 2, 5 from, and that's where this graph came from. So you'd be able to use Desmos and graph these, or just be able to do it, okay, using just your brain. And then the graphing calculator, same thing. If you pull the graphing calculator up to get these functions, you change the equal sign in the y equals. And you do that by going to second and then the math menu for test. And you can change these right here to from the equal sign. You go here and highlight this equal sign. So when you go into the y equals button, you're going to highlight that. Let's see if I can pull this up real quick. I haven't opened this calculator up for a while, so hopefully, yeah, there you go. So again, to graph these things, you got to go into y equals, okay, and make sure that it's solved for y. So for this problem right here, 2 minus 2x, okay, I would put in 2 minus 2x, but I need to get the cursor over to this right here, and I want to change that. So I'm going to go into my math button. I'm going to go into second math. So second math, and I want to change that to a greater than or equal to, right? So to a 4. So if I enter that, it'll change. And you can also go on this and highlight it and hit enter, and it should change in your setting. But right here, go to second, go to math, and I want a greater than or equal to. And it should pop up there and enter it into the, come on now. It froze on me. So my calculator froze, but it should pop into the graph and you should be able to use the graphing calculator. I just think Desmos is a little bit easier to use, but you know, to each his own. Okay. So last problem here. So find Timmy's mistake. We had a problem like this on the quiz. You know, Timmy's saying f of 6 is equal to 0. So I want you to tell me, why is his answer wrong? Okay. I'm assuming that Timmy thought that 6 should have been here. Well, 6 is greater than 3, so I'm supposed to plug that into this equation right here, x squared minus 5. So I should plug in 6 squared minus 5. It's 36 minus 5, which is 31. So if I asked you to explain, you would say, Timmy plugged it into the wrong piece of the piecewise function. Okay. We're going to look at the difference quotient. This was a bonus on your quiz that nobody got right. I didn't expect anyone to, but this is what it looks like. Okay. F of x plus delta x minus f of x all over delta x. And a lot of you I said to solve when delta x was equal to 0, and a lot of you said it's undefined. Okay, well, yes, it would be undefined because I can't plug in a 0 here, but we're going to do a little bit of math to get that denominator to cancel. Okay, and then here's the same thing, x plus h minus f of x. They're the same exact thing. This is called the difference quotient. And then I want you to write these down. So I'm going to ask you to pause the video and make sure that I'm saying memorize, but our quizzes are open notes, so you're able to do this and use this if you have it written down. So pause the video, write these down so that way you have them available. And we're going to do a couple of examples of piecewise functions, okay, or of the difference quotient. So if I give you a problem like this, and I'm telling you what f of x is equal to, and I want you to find f of x plus h minus f of x all over h. I want you to plug in these values right here for f of x plus h minus f of x over h. So anywhere that there is, if f of x is 2x plus 5, I'm going to write this as 2 parentheses x plus h plus 5. This is this part right here. Now I'm going to subtract f of x, which is 2x plus 5, and I'm going to put that all over h. So what did I just do there? I took f of x plus h. I took this and plugged it into that x value, right? And just wrote that function, right? Here's the 2. What did I plug in for x? X plus h. And here's the 5. Then I'm going to subtract f of x. F of x is 2x plus 5 all over h. Well, I'm going to do what math I can. What can I do? I can distribute. I get 2x plus 2h plus 5 minus 2x minus 5 all over h. Okay, so if I take a look at what happens here now, I can start canceling things. This 2x and this minus 2x cancel. This 5 and this minus 5 cancel. And I'm left with 2h over h. And what happens to these h's? They cancel, and I'm left with just a 2. This is going to make way more sense if you plan to take calculus and you get a little further into calculus. You're going to do something that's called the power rule that will make your life, much easier. But this is the difference quotient. It's a big part of calculus, um, something that you should be able to do and look at and say, man, when you're in calculus, I hated Mr. Lipinski for making me do this. Okay, so we're going to do the same thing here. We're going to do the difference quotient. We're going to go 2. What am I plugging in for x? X plus delta x. I'm going to square it. Minus 7 times x plus delta x plus 10. That right here is this part so far. Then I'm going to subtract the whole thing, 2x squared minus 7x plus 10. I'm going to put this all over delta x. All right. Now, I told you to memorize those because I want you to now multiply x plus delta x times x plus delta x. And we did this in our notes on Friday as well. So we're going to FOIL this out. I get what? X squared. I get x times delta x is delta x squared. Delta x times x is delta x squared. And then delta x times delta x is delta squared x squared. So I'm going to write this out. I'm going to multiply it by 2. Again, that's x squared plus 2 delta x squared plus delta squared x squared. Okay, so I'm going to distribute this 2. So it's going to be 2x squared plus 4 delta x squared plus 2 delta squared x squared. That is this part right here. Then I'm going to distribute a minus 7 delta, 7x. Let's go back here. So I'm distributing here, minus negative 7x, negative 7 delta x plus 10. And I'm going to distribute this negative. So let's see, I'm going to minus 2x squared plus 7x minus 10. At this point, you should combine anything that you can combine and cancel stuff. So I have this 2x squared, and this is all over delta x. I've got this 2x squared, going to cancel with this negative 2x squared. This 4 delta x squared, anything to combine with that? No. So I'm going to put 4 delta x squared. This 2 delta squared x squared, anything to combine with that? No. I'm going to put plus 2 delta squared x squared. So I've taken care of that, taken care of that. Negative 7x plus 7x, gone. Minus 7 delta x. Okay, took care of that, and this 10 and this minus 10 cancel. Notice this will happen every time. When I subtract f of x, all of those cancel. Every single time that will always cancel. This is all over delta x. So now if you take a look, up here, I can factor out a delta x. If I factor out a delta x, that leaves me with 4x plus 2 delta x minus 7 all over delta x. This delta x and this delta x cancel, and the difference quotient would be 4x minus 7 plus 2 delta x. So right here is this is just doing a bunch of algebra. But you will notice that when you cancel these, they always, or when you go through and do the difference quotient, your f of x always cancels. If something didn't cancel here, then you messed up your signs. Okay, so I'm going to leave a couple of these problems on the board for you to do, and I'm going to assign a couple of piecewise functions in the My Math Lab. Okay, so take a look at this video. Hopefully this makes sense and you're able to do this now. It's just a ton of algebra. It's just a ton of plugging in. And basically all you're doing is plugging in for the first problem, x plus delta x, or it's easier if you use x plus h. You end up with the same thing. But that's the end of 1.4. Hope you guys have a great night. We'll see you guys on Thursday.